Fatigue failure of a drive shaft. The drive shaft is present in the propulsion system of the boat. It broke while the vessel was sailing along the western Canadian coast. This part was made from a low-alloy steel grade 4340. The presence of fluctuating stresses, and the presence of a stress raiser are the reason for fatigue fracture. Investigation. It was found that the fillet radius present at the fracture's origin was smaller than the one provisioned by design. The broken shaft. Metallurgical characterization. Chemical analysis. The chemical analysis was carried out using optical emission spectroscopy on a roughly polished specimen cut at the part's surface. Tensile test was next carried out using an automatic recording tensile testing machine. Mechanical properties. Hardness measurements were performed according to the Rockwell C scale. The result averaged to obtain 30 HRC. Endurance limit is directly related to hardness values obtained after quenching and tempering. IC 4340 would reach approximately 30 HRC when quenched and tempered at a high temperature, around 600 C. Microstructure examination. Typical microstructure of the submitted shaft, tempered martensite, Nitrile 3% etch. Fractographic analysis. Examination of the available fracture surfaces was performed at macro scale. Any of the first features associated with fatigue initiation is the presence of ratchet marks. Ratchet marks are defined as short cracks that originate on planes of maximum shear stress. The fracture originated in a fillet radius. A smaller fillet radius at this location had produced higher stress concentration which behaved as stress raiser and caused fatigue initiation. Stage 2 fatigue is the presence of beach marks. In this case, the crack front progressed from the shaft periphery, in a slight helical direction toward the center, and eventually reached one of the shaft's sides. Near the shaft circumference, the fracture has a smooth finish, while toward the shaft center the beach marks are more pronounced. First stages of propagation were produced under high cycle fatigue, while further propagation was low cycle fatigue. Stage 3 of the fatigue propagation appearance suggests ductile fracture at macro scale. High cycle fatigue, smooth beach marks. Low cycle fatigue, beach marks with more textures. Final fracture. The rough finish, slant morphology, and the absence of beach marks. Conclusion. Shaft broke because of rotating bending fatigue. The fracture initiated at the shaft periphery, at a fillet radius, under high cycle fatigue mechanisms, which acted as a stress raiser. For grade IC 4340, the optimum fatigue resistance should be 45 HRC. Fatigue resistance, endurance limit will be improved.